In section 2.3, we're going to look at multi-step equations. In the last section, we looked at one- and two-step equations. And when we talk about multi-step equations, the goals are pretty much going to be exactly the same. Our goal is still to isolate the variable. But the key is when we isolate the variable here, it's probably going to take us more than one step. So the question is, how do we do this? And rule of thumb, you want to think of the order of operations backwards. That's kind of the first thing you want to think of here. And the reason we're going to say that is because we're undoing an equation. Well, if you're undoing something, think about a box. Whatever you put in that box first is the last thing that comes out. But before we want to do any of that stuff is, we always want to make sure we clean up our sides. And you're going to hear me say clean up each side. And what I simply mean by that is, combine like terms. Or simplify. So if you have stuff going on either side, you can combine like terms, distribute, do whatever to make the left-hand side as small, as neat, as simplified as possible. And the same thing with the right. You're going to want to do that first. So let's get into our examples. In the first example here, we're looking at the left-hand side and we're recognizing that we have a 3p and a positive 4p. Now remember, I'm putting the boxes there just to remind me that I got to combine these. So I'm going to put them together. That little step is actually going to save me some time. And now this is going to turn into a two-step equation. I did one step. That gave me the 7p. Now I do my inverse operation. Remember, we're thinking about order of operations backwards. So I do my inverse, subtract 5. Subtract 5. If it helps, draw that line down the page. That's going to give me 7p. It's going to give me negative 19. Divide by 7 because this is multiplication. The inverse is division. And we end up with a fraction. And we said before, fractions are perfectly okay. Please do not be scared of fractions. In this case, just leave it as negative 19 over 7. If you want to make it into a mixed number, feel free. If you make it into a mixed number, you end up with negative 2 and 5/7. Either one of those answers is perfectly acceptable from me. I go to the next problem. Do the exact same thing. I have a v, a negative 3v, so I'm going to get negative 2v plus 8 equals 2. If you want to draw the line, feel free. I want to get rid of this 8 first, so I subtract 8 from both sides. That means the 8's cancel, the negative 2v comes along. 2 minus 8 is negative 6. I'm dividing by negative 2. A negative divided by a negative ends up giving me a positive 3. And down here we got a little distribution going. Well, the first thing I want to do is I want to distribute my 3. Now, the 3 only gets distributed until you see the equal sign. Once you see that equal sign, please don't go beyond the equal sign. It only gets distributed to what's inside the parentheses. So this side's still a 3. Inverse operation. I get 9n. And on the right, I'm going to get 0. That's okay. 0 is a number. Divide by 9, because it's my inverse operation. Well, hopefully you remember that 0 divided by any number, in this case 9, Well, if I have 0 items and I try and put it in 9 piles, each pile is going to have 0 things in it. So in this case, my answer ends up being n equals 0. This last example is a little bit more complex because it adds another step to it. I do my distribution first. Again, ignore the 1 equals. Only focus on one side. Clean that side up first. Simplify that side. So 1 equals negative 28x plus 28. This x over here was not affected by anything. Not affected by this 7 at all, because the 7 only gets distributed inside the parentheses. Now I'm going to combine my like terms, which are the negative 28x and the positive x. It's going to give me negative 27x plus 28. Inverse operations. Clean things up. Remember, we got some canceling going on here. That's the whole goal, to cancel that out. So we get v by itself at some point. My inverse operation says divide by negative 27. And that means v is going to end up as 1. And I know this comes out as 1 equals v, but these two statements say the exact same thing. We just typically put our variable on the left-hand side.